Hello friends, in the first, which is the previous video in this series of coordinate geometry, we saw how to mark points on the xy plane, and we also saw the distance formula which is used to calculate the distance between any 2 points in an xy plane. If you want to learn all that, you can watch my previous video. In this video, we are going to solve some problems based on the distance formula. The main three types that I'm going to discuss in this video is to check if three given points form a triangle, that is the 3 points are the vertices of a triangle or not. Second, to check if given 4 points form square, that is they are vertices of a square or not. And third, to check if the given points are collinear, that is they lie on the same line. Here is the first question. Do the points 3, 2, -2, -3 and 2, 3 form a triangle? If so, name the type of triangle formed. Before we move on to solve this question, we need to recall the fact that in a triangle, the sum of the length of any two sides is always greater than the third side. So here you can say that AB plus BC will be greater than AC. AB plus AC will be greater than BC, and AC plus BC will be greater than the third side AB. Now let's solve the question. Let's begin with naming the points. A as 3, 2 and let A be our x1, y1 for the purpose of using it in distance formula. B is -2, -3 and that will be our x2, y2, and the third point is 2, 3. This will be our x3, y3. Okay, now let us find the distances between AB, AC and BC, and then later on we will see that if the sum of the sides of the triangle, the sum of any two sides of the triangle is greater than the third side or not. So let's begin by calculating the distance between A and B. We know that the distance formula is x1 minus x2 the whole square plus y1 minus y2 the whole square. Okay, so we'll just simply put the values in the formula. So x1 is 3 minus x2 is -2 the whole square plus y1 is 2 minus y2 is -3 the whole square. Okay, solving the brackets first. Root of 3 minus and minus become plus. So yeah, and then here also the same thing. 2 minus of -3 becomes +3 whole square. Okay, now we will finally solve the brackets. 3 plus 2 is 5, 5 square plus again 2 plus 3 is 5, so 5 square. Okay, that becomes 25 plus 25, that is equal to root of 25 plus 25, 50. So the distance between A and B is root of 50. Next we find the distance from B to C. So simply putting it in the formula, -2 the whole square plus -3 the whole square equals to root of -4 the whole square plus -6 the whole square, that is equals to -4 square is 16 and 6 square is 36. So that is 36 plus 16 is root of 52. And now we find the distance between A, comma C. So simply again putting in the formula, 3 minus 2 the whole square plus 2 minus 3 the whole square. That is 3 minus 2 is 1 square, 2 minus 3 is minus 1 the whole square. That is equals to 1 square is 1 minus 1 square is again 1. That brings us to root 2 units between A and C. Now we've calculated the distance between AB as root 50, that is approximately 7.02 units, and the distance between B and C, that is root 52, that is approximately 7.21 units, and the distance between AC, that is root 2 units, that is 1.41 units. Now, as I told you in the beginning of the question, that for it to be a triangle, the sum of any two sides of a triangle should be greater than the third side. So if you add AB plus BC, that is going to be 7.02 plus 7.21, that is equals to 14.23, which is greater than AC. If you add AB plus AC, that is 7.02 plus 1.41, that would give you 8.43, which is greater than BC. And if you add BC plus AC, that would give you 7.21 plus 1.41 equals to 8.62, which is greater than AB. So the condition that the sum of any two sides of a triangle is always greater than the third side is fulfilled here, and hence we can say that the points A, B and C are the vertices of a triangle, that is, they form a triangle. Our next question is type 2, that is, show that the points 1, 7, 4, 2, minus 1, minus 1 and minus 4, 4 are the vertices of a square. Before we begin solving this question, let us have a look at some of the properties that should be met before we can say that these four are the vertices of a square. So you can see a square here with the vertices A, B, C and D and two diagonals of the square drawn as D1 and D2. We know this basic property of a square, that the sides of a square are always equal. So we can say that AB is equals to BC is equals to CD is equals to AD. Again, we also know that the two diagonals of a square are always equal. D1 is equals to D2. Now, why do we need to prove that the diagonals are also equal? Because there is one more quadrilateral which is called as rhombus, which has got all its sides equal. But one of the diagonals, the two diagonals, right, in a rhombus, so one of the diagonal is greater than the other diagonal. So it is a rhombus. But in a square, along with the sides being equal, even the diagonals are equal. So to prove that a quadrilateral is a square, we have to prove that the sides are equal as well as the diagonals are equal to each other. Now let's move on back to the question. So now let's name the points. A as 1, 7, B as 4, 2, C as minus 1, minus 1 and D as minus 4, 4. Again, in this question, we will find the distances AB, BC, CD, AD as well as the diagonals AC and BD. Okay, so now let's move on to calculating the distances. I hope you have noted down the points. So let's begin by calculating AB, that is root of 1 minus 4 the whole square plus 7 minus 2 the whole square. You all know how to now put into the formula the values from the points. Okay, so this is equals to 9 plus 25, that is equals to root of 34. Now next is BC. To calculate BC, root of 4 minus of minus 1 the whole square plus 2 minus of minus 1 the whole square, because the coordinates are minus 1 of the point C. That is equals to 4 plus 1 5 square plus 2 plus 1 3 square. That is equals to 25 plus 9, that is equal to root of 34. You are already seeing that AB and BC are already equal. Now CD. To calculate CD, root of minus 1 minus of minus 4 the whole square plus minus 1 minus 4 the whole square, that is equals to minus 1 plus 4 is 3 square plus minus 1 minus 4 is minus 5 the whole square. That gives us 3 square is 9 and 5 square is positive 25. That gives us root of 34. We got three sides equal now. Now to calculate AD, root of 1 minus of minus 4 the whole square plus 7 minus 4 the whole square. That is 1 minus of minus 4 is 1 plus 4, 1 plus 4 is 5 square plus 7 minus 4 is 3, so 3 square. That is equals to 25 plus 9. That again gives us root of 34. We got all the four sides equal. Now let's calculate for the diagonals. AC would be equal to root of 1 minus of minus 1 the whole square plus 7 minus of minus 1 the whole square is equals to 1 plus 1 is 2, so 2 square plus 7 plus 1 is 8, so 8 square. That gives us 4 plus 64, that is equals to root of 68. Now BD, root of 4 minus of minus 4 the whole square plus 2 minus 4 the whole square. That gives us 4 minus of minus 4 is 4 plus 4, that is 8 square plus 2 minus 4 is minus 2 square. That gives us 64 plus minus 2 square is positive 4. That gives us root 68. So you can observe that all the four sides are equal and both the diagonals are also equal. So you can say that since the four sides AB is equals to BC equals to CD equals to DA and the two diagonals AC equals to BD, the given points form a square. Now our next question is, show that the point 3, 1, 6, 4 and 8, 6 are collinear or not. Before this, let's have a look at this. Look at the figure. You see a straight line with 3 points on it, which means that the 3 points A, B and C are collinear. Now you would also observe that the distance AC is the sum of the distance between AB and the distance between BC. This is exactly what we are going to use to solve our problem. Again, let's start by naming the points. A is 3, 1, B is 6, 4 and C is 8, 6. Now again we will find the distances AB, BC and AC and then find out if AC is the sum of AB and BC to prove that the points A, B and C are collinear or not. So let's move ahead to find the distances between AB, BC and AC. AB is equal to root of 3 minus 6 the whole square plus 1 minus 4 the whole square. That is equals to root of 3 minus 6 is minus 3 square plus 1 minus 4 is again minus 3 square. So that is equal to minus 3 square is 9 plus minus 3 square is 9. So 9 plus 9 is 18, root 18. Now BC is equals to root of 6 minus 8 the whole square plus 4 minus 6 the whole square, that is equal to root of 6 minus 8 is minus 2 the whole square plus 4 minus 6 is again minus 2 the whole square, that is equal to root of 4 plus 4 equals to root of 8 units between B and C. Now we find the distance between A, C, that is equal to root of 3 minus 8 the whole square plus 1 minus 6 the whole square, that is equal to 3 minus 8 is minus 5 the whole square plus 1 minus 6 is again minus 5 the whole square, that is equals to root of 25 plus 25, that is equals to root of 50. So now we have found the distances between AB is equal to root of 18, BC equals to root of 8, and AC equals to root of 50. Sadly we cannot add them, that is AB and BC, to find AC. We have to simplify the roots so that we can add them. So let's simplify. Root 18 can be written as root of 2 into 3 into 3, that is equals to, since 3 appears twice, so we can take 3 out and root 2 inside. Root 8 can be written as 2 into 2 into 2. So we can take a pair of 2 out, remaining 2 stays inside. And root 50 can be written as 2 into 5 into 5. Since 5 also appears twice, we can take 5 out. So 5 root 2. Now we can add AB plus BC is equals to 3 root 2 plus 2 root 2 is equals to 5 root 2, which is the distance between A and C. So we can tell that the points A, B and C all lie on the same line, since we found that AC is equals to AB plus BC. Thank you for watching this video. I hope you understood everything, all the problems discussed, and if you did, kindly hit the like button. Also share and subscribe to my channel. If you didn't understand, kindly comment below. Also, if there's any problem that you want me to solve, comment below. Thank you.